Welcome everyone. I am Tanushri Dalai from Civil Engineering branch, and today I am going to teach you your Theory 2 paper, which is Structural Design 2. So in the last class, we solved a numerical regarding tension member. So we calculated the strength of yielding, strength of rupture, and last, strength of the block shear of the plate section. And we calculated the TDB1 and TDB2 in case of block shear portion. Hence, the actual block shear strength of the plate section will be the minimum of the TDB1 and TDB2. So we got TDB1 as 170.31 kilonewton and TDB2 as 149.54 kilonewton. So the smallest one is your TDB2, which is 149.54 kilonewton. That means the block shear strength of the plate section is 149.54 kilonewton. So now the strength of the tension member in case of plate equal to the minimum of the strength in yielding, rupture and block shear. So in case of yielding, we got the value as 181.82. Then in case of rupture, we got the value 193.65 kilonewton. And last, in case of block shear, we got the value of strength as 149.54 kilonewton. That means the minimum value is the block shear one, which is 149.54 kilonewton. Hence, we concluded that the strength of the plate section in case of tension member is 149.54 kilonewton. So now we have to calculate the strength of the bolt because we need to calculate the strength of the joint of the tension member. So the bolt portion, we know about the calculation of strength of bolt in the chapter 2. So first of all, we need to calculate the strength of the bolt in searing, and after that we need to calculate the strength of the bolt in bearing. So for the searing strength, the formula is VDSB equal to FUB divided by √3 gamma MB into NN into ANB plus NS into ASB. So the FUB is 400, gamma MB partial safety factor is 1.25, NN is 1 and NS is 0 because the plate section is overlapped on the gusset plate, so that in case of overlapping portion, the NN value will be 1 and NS value will be 0. So now put this formula and all the values on the formula. So 400 divided by √3 into 1.25 multiplied by 1 into 157, which is the value of A and B. So your total value of the searing strength will be 29.01 kilonewton. So now comes to the calculation of strength of bolt in bearing. So the formula is VDPB equal to 2.5 kb dt Fu divided by gamma MB equal to, so here the kb value is unknown. So for the kb value, This is the minimum value of this 4 portion. So first formula is your E by 3D0. So in case of this figure, the edge distance is given as 30, that is the center of the bolt to the end of the plate section. So here to here is the distance of the edge. So edge distance is your 30 and the pitch distance, that means from the center of the bolt to the another center of the bolt, which is given as 40 mm. So now your edge distance is given as 30 divided by 3D0. So 3 into D0 value is 18 mm, by which the value is coming as 0.555. So now the second portion is P by 3D0 minus 0.25. So P is your pitch distance of the plate section, which is given as 40 mm. So 40 divided by 3 into 18 minus 0.25. So that answer is coming as 0.491. The third portion is FUB by FU, which equal to FUB is 400 and FU value is 410. So which equal to 0.476. And the last one is your 1.0. So the minimum of these 4 value will be 0.491. That means the KB value we will take as 0.491. So now just put this formula, 2.5 KB dt FU divided by gamma MB. So 2.5 is here, KB value is 0.491, D value is 16 mm diameter and thickness is 8 and FU value is 410. And the partial safety factor gamma MB equal to 1.25. So by calculating all these things, we will get the value of VDPB, that is the bearing strength of the bolt, as 51.54 kilonewton. So now the strength of the bolt is the minimum of the shearing strength and bearing strength of the bolt. So the shearing strength we got as 29.01 and bearing strength we got 51.54. But the numbers of bolt is 2. So by multiplying 2, the value will be in shearing is 58.02. So this is the minimum value of the strength in bolt. Okay. So now the maximum load the joint can carry safely, that is the strength of the joint in case of tension member, will be the minimum of the strength in plate and strength in bolt. So in case of plate strength, we got the value as 149.45 kilonewton. Okay, so 149.54 kilonewton is the value of strength in plate section and the bolt section strength is 29.01 kilonewton, which is twice according to the two numbers of bolt as 58.02 kilonewton. So the minimum value will be this much, which is 58.03 kilonewton. That means the strength of the plate section or the strength of the joint in case of tension member while plate is connected with a gusset, the value is 58.03 kilonewton. So this is all about your plate section calculation in the tension member. So today this much. We will discuss another problem in the next class. Thank you.